Hey, hello. Welcome to my HashiTalk. I want to discuss today the world of Puppet and the HashiCorp Stack. And it came to me, this talk, as one day my boss came into my office and asked, we should do this cloud thing, build me one. And this is basically my walking through the way of building ourselves a self-service instance where developers, other engineers can build their own infrastructure. So first of all, I would like to discuss infrastructure as code. As in traditional operations, we've always thought of infrastructure as code as operating level and up, but since we're now in the cloud, and that's also basically API based, that's a new layer of infrastructure of code that we can model and build and describe. So the first problem you always have when building your own cloud is when you come from a traditional operations background, is you can't Pesky boot a cloud. There's no such thing. And so you need to build yourself a base image that you can upload into your cloud provider. HashiCorp provides a very nice open source tool called Packer for this. It supports multiple cloud providers. It provides multiple local virtualization tools, and it allows many hooks to post and install stuff. Then it can create artifacts with post-processors, which you can then upload either to your VMware or to Azure or AWS. So let's have a look what that looks like. Packer basically uses JSON templates to define and model your the operating system. In this example, we're building an Azure base image, which you can see here by the type. And then afterwards, I basically install Puppet using a simple script that is on my local host. And then try to connect to a Puppet server. Well, it sets a variable called Puppet server. And then it's very easy to build this image using a command called packer build, and then your JSON file. That yields you a VM that you can then later on use to bootstrap your cloud. Then how we integrate Packer and Puppet, I briefly mentioned it in the previous slide. This is a script that now a former Puppet Labs employee, now a HashiCorp employee called Peter Suter maintains, and that you can easily install using the script any active version in the Puppet Labs repos. And of course, when you build your own cloud, you want to test it locally. And HashiCorp has a tool called Vagrant for this. It's the original HashiCorp tool that allows you to have spin up, configure, manipulate local VMs. And nowadays, it also supports things like Docker, but it started out as VMs. And then it has hooks with several provisioners like Puppet, like Chef, like Ansible to configure your local machine, so you don't have to write bash. So if you want to, you can. Let's have a look at a sample configuration file for Vagrant. Vagrant, the DSL is basically Ruby, so anything that goes on Ruby you can write in a Vagrant file. And here on the screen is a slightly elaborate version of bootstrapping your node using local Puppet code. So a masterless setup where you map a folder or directory from the outside to the inside and then point the Puppet installation to it. This is a masterless setup. Of course, you can also use a master client setup like you would normally use in a Puppet setup. You would spin up a node, a Puppet master using the masterless setup, and then the additional VMs would connect to your freshly spun up Puppet master. And then they would be configured using that Puppet master. Setting some defaults. In my case, it's always puppetmaster.environment.vagrant. Then you set up some variables to connect to said Puppet master. And of course, when you're developing your Puppet code locally, you want to build, destroy, configure in a rinse and repeat cycle. So here at the last 4 lines, I'm showing a simple way of letting Vagrant clean up your certificates on the local Puppet master after every run. It used to be a script, now it's built-in functionality of Vagrant, which is very nice. That cleans up your local Puppet certificates. Then, of course, it works locally. Now you need to go into the cloud, for which HashiCorp provides a very nice tool called Terraform. It's an open source, again, open source automation tool. It's very cloud-oriented. And with cloud, we mean clouds are APIs, so it's API-oriented. Terraform, Terraform uses, again, a plugin-based system. So for any CRUD API you have, you can pretty much write your own provider. So let's have a look at what Terraform means. You can model your infrastructure. You make a plan, then you apply the plan. And then if the current state is saved for future changes, so that we can always come back later. We can additionally add some more infrastructure to our platform, or remove it, or configure it in a different way. Terraform uses a HashiCorp specific configuration language, which uses which is a modeling the DSL similar to configuration management tools like Puppet. It uses a desired state so that you can describe things in a simple way. So when you do a run, you can always reach that desired state, or the tool will try to reach the desired state. The HashiCorp HCL language is used in several other tools other than Terraform. So let's create that our first node. Let's go into the cloud. So here I describe as a node for an Azure virtual machine. That's going to be our first Puppet master. You can pass in several variables, as you see here. You can reference other resources, like for instance the network interface ID that we take from one of the other resources, and then pass it into here. There's several other functionality, like choosing your disk size, and then here comes in the image we built before. So the storage image reference is the reference to the Packer image we built before. So how do we bootstrap this Puppet master? That's basically a simple script. I'm building here a Debian machine. We go apt-get install server. First of all, we create our certificate. Then I need to clean it, because in Azure, like any other cloud, we get a user host name that is not really memorable. So you want a vanity DNS name that people can easily remember and reach. So I create the certificate, I clean it, then I sign in an additional user of a host name using the DNS old names, and then I restart the service. Now we're ready to bootstrap other nodes. So this yields us a chicken and egg problem, because if I don't know the Puppet master, I cannot configure the Puppet master, and to configure the Puppet master, I need the Puppet master. So we're basically down to a DNS problem. And luckily for DNS problems, HashiCorp has also created a tool called Consul. It's an open source tool that allows us to do service discovery. It has a built-in service mesh tool, and it also provides a built-in key value store where we can store and retrieve values if and when required. So let's install Consul. We're going to put it on top of our Puppet master. It's a simple module that's available on the Puppet Forge. Has a couple of simple configuration options, and then we can set up a Consul check that where we ask Consul to check a service and basically announce it into the Consul cluster. Here we set up the Consul check for our Puppet master. It needs to listen on the standard Puppet master server, so 8140, and we announce it that it's to be the service Puppet master. Since Consul is a DNS tool, so we can now dig for our local query, and then it will bring back any service that is registered, any node connecting to the service you're requesting. So the way Consul builds up DNS names is always service name.service.consul, and it's an easy way for people to find any services. We can even set up geolocation specific information, so we can set it up in such a way that it always connects to your local DC, and when the local DC, SAT server is not available in the local DC, it can fail over to another DC. Consul also allows us a way to speed up the way exported resources work in Puppet. So exported resources are a tool that allow us to define something on one node and then have it expressed on another node. This normally takes 2 Puppet runs, one on the original node and one on the node needing to express the thing. So in a worst case scenario, you will need to wait an hour for your service to come online, because Puppet normally in normal setups only runs once in half an hour. So in the worst case scenario, you have to wait for 30 minutes. Consul has a nice tool called Watch, so we can now detect changes in the services. So a new service comes online that triggers an event in Consul, which the Consul Watch picks up, and then it can actually trigger the Puppet run on the second node, basically reducing the time required for your infrastructure conversion down to 2 Puppet runs. So let's magic that second node. We thought it's pretty much the same thing as building the Puppet master, but now we need to bootstrap a second node, and in the bootstrap we need to connect to our Puppet master or our Consul cluster that will then tell us where the Puppet master is. This is done using a simple cloud-init script that in Azure is called OS Profile Custom Data. Let's have a look at the script. So for the people that were paying close attention, we worked out that even though we now have Consul to connect to our Puppet servers, we cannot connect to Consul yet because we have no idea where that lives. HashiCorp has built in a nice tool where Consul can actually go into your cloud provider using the credentials, some credentials you provide, and then work out based on tags what nodes it needs to connect to, and then it tries to join the cluster using that way. And then after that, there's a simple Puppet agent -t -s server, and then Puppet master service.consul. So we're getting close, but we're not there yet. We can now build our services. We could technically give our colleagues access, but we still have some problems because we cannot be sure that we haven't given our colleagues the tools to do the self-service. So it's quite manual still. They still need to know about how stuff gets bootstrapped. Plus, most of the bootstrapping is based on facts in Puppet. They're nice, they're useful. They're also highly insecure because they're user changeable. So when a node comes back with a certain information, one can never be sure it's the actual information because a bad entity could have changed it on the local machine. In this case, we manipulate some files based on a certain Puppet version, but it could also be the role or the credit card provider or such a thing. So we need to be very careful with Puppet facts. Luckily, Puppet provides us a way to trust our facts a bit more. So it gives us an option to sign facts into our certificate. Puppet uses a master client connection based on a signed certificate by the designated CA. By providing a certain file, we can sign additional information into the certificate, which later on is usable in Puppet as trusted facts. In this case, I'm signing in my environment into the certificate and the role and the network and a couple of additional information that we might later on use. The trusted facts can then be used in a slightly different way than we're used to. It lives in a different namespace than standard facts, but we can use it in our Puppet code by using the $trusted extensions, and then again the fact that we specified. So this way we can always be sure that the role is the one that we want it to be. So let's extend the cloud-init a bit further. We've seen the Consul connection before. Now we're adding the creation of the CSR attributes file, and then we connect to our Puppet master. This yields still a bit of trouble because any old person can now connect to your Puppet master and basically can mimic any infrastructure you're building. So Puppet has built a built-in thing called policy-based autosigning, where the Puppet master can reference an external script to check if it is allowed to sign the certificate. It's a simple setting in the puppet.conf called autosign, and if you switch that to a script, then it will use a script to check the certificate. I'm showing a fairly simple setup here that goes into your certificate and checks if the key we specified is set, and you can extend this script up until nice web-based interfaces where people can request a certain allocation of resources or whatever your CMDB can provide you here. That leaves us one last thing. It's Pesky Passwords. They're in the way we're used to in Puppet. They're basically everywhere and anywhere in your, hopefully only your Hiera code. So it's at least separated from your Puppet code, but basically most passwords are open in text, which if you're starting to do self-service is perhaps not what you want to do. So HashiCorp provides a very nice open source tool called Vault, which is a password secrets manager where we can offload the secure storage of these passwords. Again, Puppet code, it's very simple. It's a module we can find again on the Puppet Forge. We can simply install it with some basic configuration, and then we can start submitting our secrets into Vault itself, which is simple by a command line tool called Vault. And then we use Vault write key value, and a name value is value, and then it gets sent in there, and then we can query it if and when we have authorized to Vault. Vault can then be used as a Hiera backend, similar to what we're used to, like the JSON or the YAML backend. And a nice feature in Puppet 5 is that we can narrow down when Hiera goes into Vault and tries to work out if the password is available. So in this example, I'm showing here a setup where we go into Vault through Hiera only when my keys start with the word sensitive or start with the word password. Any other time this Hiera backends gets bypassed, and therefore we will not have a load on Vault, and Hiera will return more quickly. It's a similar to other backends. We can specify when it needs to go into Vault and where Vault can be found. If we then have a look at how we're using it, I'm showing here a class called Profile MySQL, where we go in and we want a sensitive password, so it will never show up in our notices anyway, because I've declared it sensitive. But originally we would have a password here. Now we can actually use Vault to store the password on disk very securely. In Puppet 6, there's a new thing, so you don't actually have to use the Hiera backend anymore. You can now have user-specific, node-specific functions where the local node, so no longer the Puppet master, but the local node that is applying its catalog goes out to Vault and requests only the keys that it needs at that point. So even less load on Vault and a far more spread load. So we need to enable certificate authentication on Vault. Then we need to configure Vault to use our Puppet certificates, because we already have those. We have a way of replacing those, and we have a way of managing those. So let's use the Puppet certificate for that already. It's another module that we can download off the Forge, and that way we can actually have a deferred lookup during our local catalog application, which the code changes a bit, but the principle remains the same. During the application, it does a Vault lookup to password MySQL in our local Vault setup. So that brings us to the end. Hopefully I've shown you that HashiCorp has fantastic tools that will help us build our cloud. Things like Packer, Consul, Terraform are invaluable to the way we work right now. But by applying Puppet on top of these tools, we can have full control over our cloud, what happens there, how we configure it, how we can do second-day operations, and keep it in a well-known state. And hopefully I've also shown that we have a very distinct line where we switch from one to the other, so that we can have full control over our infrastructure while not being blocked by any other tool or way of working that we would like to have. So thank you for your time. Hope it was informative. Thank you very much.